Hello, folks. Welcome to 4.2, relationships between two quantitative variables. So last time we talked about two categorical variables. Now we're going to talk about two quantitative variables. And the big thing when it comes to quantitative variables, or two of them, is scatter plots. So the scatter plot shows the relationship between two quantitative variables. So relationship between two quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis. This one would be the explanatory variable, just by the way. And the values on the other variable would appear on the vertical axis. This would be the response variable. Remember, we talked about those back in 4.1. And each individual in the data set appears as a point in the graph. So there's nothing really to fill in here, but a lot to talk about. So how to make a scatter plot? Well, you're going to draw an x and a y axis, and you're going to label them. Remember, the x-axis will be the explanatory, the y-axis will be the response. You're going to scale the axis. Now, this is important. We don't necessarily want to just go from 0 to whatever. We're going to just basically make sure we cover the min and max values for each axis. And you're going to see we're going to do that in our scatter plot down here in a minute. But scaling it, very, very important. Now, plot individual data values. That'll be straightforward. We just plot them. To use technology, if we ever go to StatsMedic for this, we will go to two quantitative variables at the StatsMedic website. Now, to describe a scatter plot, so this is going to be, it's kind of like SOX. Remember when we describe a distribution, we talk about SOX, shape, outlier, center, spread. But when we describe a scatter plot, it's going to be DUFs or DOFs. It depends on how you want to see this letter here. So U for unusual features or O for outliers, so same thing. So D is direction. Direction is either positive, negative, or no direction, no association. So U or O, unusual features or outliers. Form, form is the overall pattern, whether it's linear or non-linear, which would mean it's curved. And then S is for strength, how much the point deviates from the others, essentially. It can be weak, moderate, or strong. So if there's very little deviation one point to the next, it's very strong. But if the points are pretty scattered about, that would be pretty weak. And then moderate, somewhere in between. So let's make a scatter plot. So here we have some candies from movie theaters. And we're comparing sugar and calories. So these are the two variables, sugar and calories. Now, sugar is our explanatory variable. Calories is our response variable. We're going to use sugar to help us predict the amount of calories. So let's get into it. So our scatter plot, let's make our x and y axis. So remember, the x-axis is going to be sugar, and our y-axis is going to be calories. Now, again, we're not going to scale the axis from 0. We're going to go kind of look for the min and max and make sure we range it properly. So looking at sugar, we have, looks like 12 altogether, right? 6 here and 6 here. So the lowest number I'm seeing in sugar is this 44. And the highest number I'm seeing is that 136. So I have to go from 44 to 136 on this number line. So to even it up a little bit, let's go from 40 to 140. Oops, not 14, 40. From 40 to 140. I think that'll work out nicely. And let's do 20s. But, you can go by 10s if you want to. I'm just going to go by 20s for mine. 60, 80, 100, 120, and 140. All right, so that should cover everything that I need. Remember, 44 to 136, so that's perfect range for that. Now for calories. Now, again, we don't just want to start from 0. We want to look for the lowest and the highest. So the lowest for calories I see is 350. And the highest I see for calories is 790. So I have to go from 350 to 790. So I'm just going to go from 300 to 800. And I'm going to just go by hundreds. Now you can go by slightly different amount if you want to. But again, the main thing is don't go to 0. Don't start at 0. Just start where you need to start. To make sure that you have enough room for it. So yeah, 350 to 790, this should definitely fill it in without leaving too much extra space that's not used. So yes, only go where you need to go. All right, so let's start plotting the points. Okay, so the first one we have is 45, 450. So 45 for sugar is going to be right about here, and then 450 for calories is right about here. So mapping those together, that's probably about right there for that point. All right, I'm gonna go ahead and do the rest of these. So 107, 570, 107 would be right about here, right? And 570 is gonna be way up here, so probably something like this spot there. I'm gonna pause the video just to not take up too much of your time, and I'll come back with all my points plotted, okay? All right, so here are all my points. There are 12 of them to match the 12 up here. So if you need any help plotting the points, let me know. But this is all of them. And so now what I'm going to do is we're going to do number 2, which is describe the scatter plot. So remember, describe, we're going to be doing the DUFs or DOFs, whichever way you want to look at it, or whatever you want to call it. But yes, D for direction. So the direction, remember, if you go back to our notes there, direction, we have positive, negative, or no direction. So you can see there's definitely an increase in the pattern here. So more sugar means more calories. So direction, I would say, is positive. Positive direction. More sugar means more calories. All right, let's look at the U or O for unusual features or outliers. I would say the most unusual point is this one up here, because you can kind of see the rest of these kind of are pretty much gathered in this increasing line, but this one just kind of has an unusual spike all the way up there. So that one is the Reese, or not the Reese's, the peanut M&Ms one. That's 79,790. So this peanut M&Ms point is a bit out of place, so I'm gonna go with that as my unusual feature. So peanut M&Ms is out of place compared to other candies. All right, now F is for form. Remember, form is whether it's linear or non-linear. So if I drew a line of best fit here, would I curve my line of best fit? Do I have a curved pattern here, or do I have a straight pattern? And for this one, I would say it's mostly straight. So I would say for form that this is linear, because the data is mostly in a straight line. And then finally, S is for strength. So strength, remember strength, if the points are kind of in a row and very compact and not very spread out, that's a very strong correlation. If they're really spread out, that's weak correlation. And if it's in the middle, somewhat moderate. So these are fairly spread out. You can tell they're definitely not in a row, but I can generally still tell the direction that they're in. So I would argue that this is more of a moderate, positive correlation. But strength, I would say, is moderate. It's kind of weak, but it's not too weak. So I would say moderate strength. All right. That's going to cover it for the scatter plots. I'll see you guys, I guess, in 4.3. Bye for now.